Right, I have set my camera and yeah. Right, guys. So welcome to another video of me explaining some science stuff. Well, this is not some random science stuff. This is gonna be really important for you guys, especially if you're doing like stuff like A-level physics and all. So if you're doing A-level physics, watch this. And I'm trying to make it short as possible because you can save much time. All right. So majority of you guys watching this video right now must know the first law of thermodynamics, which is the law of conservation of energy, law of conservation of mechanical energy. And I have my notebook in here. I'm going to show you exactly what that means. So, what does the first law of thermodynamics state? So the first law of thermodynamics says that the total energy in the universe is constant. It doesn't directly say that. It directly says that energy can neither be created or destroyed. Yeah, that means energy cannot be destroyed. How are you gonna destroy an energy? You cannot destroy energy. Like, let's say I burn this book, right? I burn this book. This book has a physical energy, and if I burn it, it's gonna be ashes. You can't destroy it, and some part of it is going to be liberated in the form of gas. So you can't destroy energy. You get me? And in this video, we're going to be talking about the law of conservation of mechanical energy. Basically, the conservation of mechanical energy. Yeah. All right. Let me get a new page and do it for you guys. All right. So I'm going to write down here the law. Actually, you know what? Yeah, I already written it down. The law of conservation, proving conservation of mechanical energy. So I'm gonna prove it to you right now, the conservation of mechanical energy. Alright, I've got this keys right here. It's keys for my bicycle, whatever. So I'm gonna, so right now, what's the gravitational potential energy? Right, the gravitational potential energy of this set. I'm holding this key right now. So right now, the gravitational potential energy is not zero. The gravitational potential energy is only zero when it's on the ground. Now it's zero. What's the initial velocity? Zero. Zero, so. Let's talk about the key. I'm gonna draw a diagram for you guys. I'm going to explain it to you what that means. Alright, so let's divide the falling of the key. Alright, I'm going to hold this key, it just fell. I'm going to divide the falling of the key into three parts. Number one, at the holding point, this is point A. Number two is the point B, mid-air, alright? And point C is when it touches the ground, when it falls on the ground. Right. Yeah, that's my diagram. Do I really have to draw that again for you guys? I can just show you the old ones. But no, I'm gonna draw it again for you guys. So subscribe. I'm drawing a whole new diagram for you. Literally. Alright, so at point A, I hate this pen. Do I have any other pen? Yeah, that's right. So point A. Right, my key is at point A right now. Just imagine this key is here above the ground at point A. And right, and this is the ground, right, and this is mid-air, and that's point B. Let's call mid-air point B, and let's call the ground point C. And the thing is, the whole distance from point A to point C, let's call it h, height, alright? That's the whole distance between point A and point C. That's h, alright? That's h. And yeah. the distance between point A and B, let's call that x. That's x. And so guess that. Guys, just guess. Just take a guess. Right, what's B? What's B? The whole distance between point A and point C is h. And the distance between point A and point B is x. So what's the distance between B and C? Obvious, it's obvious, guys. It's h minus x. H minus x. H minus x. You've just got h minus x, right? Hope you can see that. Can you see that? Yeah. I know it's very small, but sorry. Alright, anyway. Alright, now it's time to calculate the gravitational potential energy, the total energy. We're gonna prove that the total energy is gonna be constant. Right? The total energy is always constant. It's never gonna change. So what's the total energy of let's say at point A? This is point A, I'm holding it. The holding point is called point A. What's the energy, total energy of this key when I'm holding it at point A? So we're gonna have an equation at point A. Point A. So what's the gravitational potential? What's the equation for gravitational potential energy? mgh, right? So gravitational potential energy gives you. Oh, I'm sorry. My handwriting is terrible. But the book is like upside down, actually. So the potential energy is mgh, alright? What's the kinetic energy at the top, at point A? 0. Alright, kinetic energy is 0. So what's the total energy? The total energy is the sum of all energy, right? The sum of gravitational potential energy and kinetic energy, which is mgh. mgh plus 0 gives you mgh. So the total energy equals 0. Sorry, it's mgh. I'm not being so stupid. The total energy is being mgh, alright? That's the energy at point A. Now we're gonna calculate. Alright, so this key is at point A. Now I've just dropped it. Alright, I just dropped it, and now we're gonna calculate the energy at point B, which is mid-air. So what's the energy, total energy of this key at mid-air? Let's say, obviously I can't stop at mid-air, but yeah, mid-air, stuck in mid-air. Let's just imagine. What's the energy now? So right now, the energy is going to be at point B. At point B. What's the potential energy? So at point B, the potential energy, mgh again. It's mgh. mgh, right? Can you see that? Yeah, it's mgh. What's the kinetic energy? So, in order to calculate the kinetic energy, it's not 0 because it's moving. It's moving towards the Earth. So the kinetic energy, guess it. We all know the equation for kinetic energy is half mv squared, right? So we're gonna get 1 by 2 mv squared. 1 by 2. Can you see that, guys? 1 by 2 mv squared. And we need to get the v square, alright? We need to get, so m means mass, and v is velocity. It's too hot, man, can't lie. So the equation for velocity is v squared equals u squared plus 2as, alright? V squared equals u squared plus 2as, and here u squared means the initial velocity, 2 is just 2, a is acceleration, and s is displacement. By the way, a means acceleration due to gravity, which is like 9.8 meters per second squared. We can just say g. So here A equals d, s equals displacement, which is the h. Alright, the height is s, so we're gonna get kinetic energy equals 1 by 2 m. What's v square? V square is, so initial velocity is 0. Let me just, alright. So u equals 0, which is initial velocity. Alright, wait. U equals 0. A equals g, and s equals h. Can you guys see that? So the initial velocity is 0, a equals g, and s equals h. S is the distance. So the kinetic energy, we're going to replace the u, the v, sorry, not the u. We're going to replace the 1 by 2 mv square. We're going to replace the 1 by 2 mv from mv squared. Kinetic energy equals 1 by 2 m times 2, right? Replace 1 by 2 m times 2 gh. We're going to get a gh. Can you see that? I'm so sorry, my handwriting is horrible, guys. Alright? We got 1 by 2. Can you see that? This 2 and this 2, they can cancel out. So what do you get? We get 1 times m times gh. Alright. So the kinetic energy equals mdh. Right? I've just made a horrible mistake. A horrible one. I just calculated the energy at point C, guys. I'm so sorry about this. I just calculated the energy at point C. I'm not going to record this video again. I'm sorry. Alright, so what does that mean? That means... so let's find the total energy, right? Total energy. The total energy is kinetic energy plus potential energy. And here, potential energy equals 0. Kinetic energy is mth. So the total energy is mth. mth. And by the way, that's not the energy at point B. That's the energy at point C. At point C. I'm sorry. And now we're going to calculate the energy at point B. So what happened is, instead of calculating this, the energy of this key in midair, I calculated its energy when it hit the ground. This whole time, I was actually calculating the energy of this key when it just touched the ground. That's so funny. Anyway, if you're learning it, this is the energy of this key at point A when I was holding it, and this is the energy, total energy of the key when I threw the key and it touched the ground. Right? Cool. Now we're going to calculate the energy, total energy of this key when it's in midair. Alright. Yep. Yeah. Right. So at point B, we're going to calculate point B now. It's going to be pretty easy, actually. So, at point B, what's the potential energy? So, here's where I made the mistake. The potential energy at point B equals mdh, but it's not h, because the potential energy means, potential energy. Potential energy means the mass times acceleration due to gravity times the height. So we have to take the height at B. Do you see this? So the height at A, what's that? It's at the top. There's no height above that. So height at B, it's h minus x. That's the height at B. The height at C is h. Alright? I took h as the height in here. Right? That's when I realized it. Anyway, so sorry for you guys. For myself as well, because I forgot that. I'm wondering if I have a memory loss issue, whatever. Alright, so at B, the height is h minus x. Can you see that? So instead of writing mdh, we're going to write md times h minus x. md times h minus x. My handwriting's like very small, you guys can't see it. So here, I just wrote the potential energy equals md times h minus x, alright? And I'm going to calculate the kinetic energy. Pretty much the same like point C. The kinetic energy is going to be mdh actually, but we're gonna write mdx because here we're gonna write mdx, alright? Because we need to cancel them out. I'll explain to you what that means in a second. Alright guys, I just had to go out and I came back. By the way, now we're gonna take a whole new page so that I can explain to you guys exactly what we're doing. You obviously know what you're doing. You should know what you're doing. So, where were we? Yeah, we were calculating the total energy at point B. So, potential energy equals md times h minus x. We're calculating kinetic energy, and we got mdx. That's the kinetic energy, right? And the total energy is obviously potential energy plus kinetic energy, and that is, oh, I can't write it this way, come on, PE plus KE. Alright, just gonna give you, so what's the potential energy in here? mdh minus x plus mdx. Now I'm writing in big letters. I mean, at least a bit bigger. Look, as you can see, the total energy is mdh minus x plus mdx, and we're gonna prove this is equal to mdh. So, which implies we're gonna open the bracket in here. So it's gonna give us mdh minus mdx. mdh minus mdx. Then we're gonna write plus mdh, alright? Plus mdx, not mdh, mdx. Which implies mdh. So what happens in here is, you see that minus negative mdx and positive mdx, we're actually cutting that down. We can cancel them out and we're gonna get mdh. Cancels out. mdh is the answer. So as you can see that the total energy at point A is mdh, total energy at point B, which we just found, is mdh, and the total energy at point C is also mdh. Do you see that? Do you just see that? So that means if I'm dropping this key here, the potential energy is 0. The potential energy is mdh. The kinetic energy is 0. I dropped it. When it hits the ground, the kinetic energy is 0. The potential energy. Why does it always happen when I say potential energy? I don't know why. Anyway, the potential energy at the ground is 0. Kinetic energy is at the top. Yeah, so you get mdh. And yeah, that's it. So we just proved the conservation of mechanical energy and the first law of thermodynamics, which is energy can neither be created or destroyed. Yeah, that was a big thing. Oh, not very big, but yeah, kind of big. Anyway, guys, I know these videos, I'm just making like silly mistakes, but the reason why I do them is because this is not scripted. I'm not some random teacher or a scientist or a researcher or whatever doing this to make money or to get likes or subscribers. I'm just giving you guys what I know. I'm just giving you guys stuff from my brain straight away to the camera. Yeah. This doesn't really have script or something. Anyway guys, I'm speaking too much. Bye for now.